and welcome to today's video. We'll be talking about some new features in Actable AI's clustering analytic. Clustering, also known as segmentation, is a technique used for grouping a set of objects or data points based on their similarities. It is an unsupervised learning method that aims to discover inherent patterns or structures in the data without the need for predefined labels or classes. Techniques that need to use such labels are known as supervised methods. The goal of clustering is to partition a dataset into distinct clusters where objects within the same cluster are more similar to each other than to those in other clusters. The similarity or dissimilarity between objects is measured using various distance or similarity metrics such as Euclidean distance, cosine similarity, or correlation coefficients. Clustering algorithms analyze the data and assign objects to clusters based on their proximity in the feature space. Clustering has applications in various domains, including customer segmentation, anomaly detection, and recommendation systems. In this video, a popular dataset will be used to segment customers based on their credit card usage using the Actable AI platform. So once the data has been uploaded to the platform, either as a CSV file, an Excel file, or by connecting directly to a dataset, we can then specify our options in the segmentation analysis analytic. So first we can see the time section where we can specify any columns related to time, which we can also use to filter. In this case, we don't have one. Next, we need to specify the number of clusters that we want. So this is dependent on the task at hand. In this problem, we started with 4 clusters. Then we need to specify which of the features will be used to color our data points and the results. By default, it's the cluster ID, and normally it's fine if we keep this as the default value. The filters field will allow us to filter our data points by any feature that we need. Selected features are the features that we will want the clustering algorithm to use to determine the similarity between the different points. Extra columns are used to display any columns that were not specified in the features above, but they are still displayed in the final result. Similarly, also for the displayed columns, they will be displayed when we hover over the data points, even if they are not used in the clustering model. We can also specify explained predictions to determine why certain clusters were chosen for each of our data points. We will see this in more detail later. Max-train samples determines how many samples we can use to determine the clustering. This is useful if we, for example, want a shorter training time, because the less samples that we have, the lower the computation time. However, the accuracy will also decrease. So this is a trade-off between the two different factors. Finally, size will determine the size of our data points. So in this case, we have already run an analytic here, and we also used these parameters here, the clustering model and the projection model. These are new features that have been recently introduced in Actable AI. So the clustering model options include the Affinity Propagation, Agglomerative Clustering, DBSCAN, Deep Embedding for Clustering Model, or DEC, the classical k-means, and also Spectral Clustering. In this example, we used k-means to start with. There are also several different options that you can specify. Usually the default values are quite good, but obviously you can fine-tune them to your own tastes. Then, to display the points into a 2D space, we need to use a projection model. So in this case, we have different options, namely linear discriminant analysis, T-sne, or UMAP. Again, there are several options that we can choose. Finally, we can also specify the color scheme to use to display these points. Once we are happy with those options, we can click run, and then after some time, we will see the results here. So we can see that there are 4 roughly different clusters here, okay? And if we do hover over the points, we can see the value of the cluster along with the values of the features of each point. In the clusters tab, we can see the decision behind each cluster, specifically the features and thresholds used to assign a sample to each cluster are shown, along with the percentage of samples satisfying these criteria. So these are very useful to get a better understanding of how these data points were chosen and segmented into the different clusters. The Data tab shows the features used in the segmentation and also provides some additional information, namely the cluster ID, that is the name or number of the cluster, the X and Y coordinates of the data point in the 2D space, along with the rest of the features used. Finally, we also have the table here, which shows a select number of samples in our original dataset. We can, of course, vary these options to determine if it's better or worse and fine-tune our results. So in this case, we use k-means and UMAP. What if we use DEC, which is a much more advanced method? In this case, we can see that the end result is much more pleasing. There are 4 very clearly separated clusters, albeit with some noise at the edges. And in this case, we used LDA. We can also try out other projection methods, such as T-sne, that we can see here, and also UMAP that we used for our first model with k-means. So again, we can see that in this case, they are much better separated. Again, we can then see the reasons behind the chosen clusters and all the different thresholds that were used to categorize our different samples. If we increase the number of clusters, in this case we have around 14 clusters, we can see that there's still quite good separation between the different clusters, although perhaps it might be a bit too much for this problem. In this case, we also enable the explain predictions option, which we can see here. These values in green and red are the Shapley values, giving an indication of a feature's contribution to the outcome. Values in red indicate that the feature decreases the probability of the predicted outcome, that is the one with the highest probability, by the given amount, while values in green determine that the effect of the feature increases the probability of the predicted outcome. That is, in this case, the assigned cluster. And again, this helps us get a better understanding of how the model is performing its predictions. And this is another tool that is used for explainable AI, which is one of the core features in the Actable AI platform. This brings me to the end of this video. If you want further information, you can also consult our documentation, where you can find all the details on the available settings and example use cases. Thanks very much for watching, and see you again soon.